we had you up there now. Page 377, what?
18B.
Anyways, this is back to the casino, right?
Yeah, the roulette.
How do you spell roulette?
R-O-U-L-E-T-E.
Is it double T? Okay, so what was I gonna say? Yesterday, Milad asked me why can we use a binomial for this? And I said, yeah, the scenario is binomial. Why was the scenario binomial? It is a binomial scenario. Why is that the case?
Because each trial is independent from the other.
Yeah, we actually didn't deal with multiple trials in our case. We would always talk about one trial. But if you were to deal with multiple trials, like bet again and again and again, probability of success doesn't change depending on what happened before. It's constant. However, we defined the random variable x in that question as the payout per bet, per specific bet type, if you will. Per $1 bet, right? So like it was like $35 you pay, or you
pay $1
or you receive $1, and so on and so forth. But for binomial probability distribution, what is the random variable x always defined as? The number of successes out of n trials. So you could create a binomial scenario, but it doesn't apply to the way I was solving the question. I was defining a random variable differently, right?
So if you define it differently, you can solve it.
Well, no, it was like the question called, in my mind, it was the way I solved it, for a certain solution which involved defining a random variable x, which was not a definition of successes out of n trials. In fact, in every case, I was just dealing with one trial, right? It was one bet, and then you pay out this much or you lose this much, and so on and so on. So it wasn't. The scenario could be modeled in a binomial way. That would be more like, if you did this kind of a game, what is the probability that if you bet on choosing one number correctly and you played the game 10 times in a row, what's the probability that you would win 6 times? Then you have binomial distribution. And then if you want to know the expected value or the average number of times that you would win out of those 10 trials, then you do NP. So you would say, okay, well, n is the total number of trials, and p is going to be the probability associated with each one of those trials, which is constant. You multiply the two and you get that. But that's not what we were doing, right? In each of our cases, we were just doing one single bet, right? And we were looking at the expected value per single bet of the amount of money that the casino would pay. Wait.
The casino makes.
It wasn't payout. It was
Receive.
Receipt. Dollar receipt per specific bet type by casino. Receipt by casino, right? Or house, or whatever they call it. Okay, so then what's part B?
Part B. Estimate the weekly profit that a roulette wheel could make for a casino. List the assumptions you have to make for your calculation.
Are you kidding me? Well, profit is going to be revenue weekly, right?
Yeah.
Okay, so we know what was our revenue? What was it? It was like $2/28 per bet.
38.
$2/38?
Yeah.
So it's like $2/38 per bet. You'd have to multiply by the number of bets per day, right? All right, times we'll say question mark bets per week, right? So that would be the revenue that you generate from this. But then what about other games? Maybe you have other revenue streams, right?
No, but it's asking for roulette.
Oh, for roulette, okay. And you have to subtract that from your weekly expenses, so I don't know. You have to pay the dealer, right?
I don't think they're asking.
No, we don't have to worry about dealer. Just
just the money they put in.
Just the money that you give away, basically.
Yeah, but this is This is the amount of money that you're making.
We can do whatever we want since they didn't want to
Oh, nice one, Mr. Secretary. I'm just gonna write this down.
We can do the question however we want.
That's the end. Well, that's what I'm doing. But the point is, I don't know what my weekly expenses are. So this is how much money the table is generating. This is how much money the table is generating per week, right? I don't know how many bets are made per week.
That's what you assume.
I know, but that's my answer. I'm leaving it vague. It's stupid. So it's going to be that much money that I generate per bet times the number of bets per week. Subtract the expenses per week. And that'll tell you how much money you have. You got to pay the dealer or whatever the guy is who sits at the roulette wheel. Maybe you have to pay for maintenance, etc. I don't know. That's my answer. What's C?
European roulette all deals have only 1-0. Describe how this difference would affect the house advantage.
Okay, there's only 1 0.
Yeah.
So what was
the
it?
double
before?
zeros are out?
So it was 1 to 36, right?
Yeah.
And then it was
0 and double zero.
so before we had 0 and double 0,
Yeah.
which was a total of 38. But now you're taking out the double 0.
Yeah. So it's 37.
So they give him more money.
So that means the house is in more trouble
Yeah.
because now
It's not
the
in more trouble. They
Yeah, it
get
is.
less money.
they give out less money.
They get less.
They get less money.
Yeah. So
Yeah.
they're in trouble.
So the house is.
Lose.
That's what I mean by more trouble. It's not good for the house.
They are going to find my field.
Lowers
There's no other way.
lowers revenue.
The one thing is
Right? Agreed?
Yeah.
And why does it lower revenue for the house? Because the probability,
Getting a loan.
since probability of success
Because green is
a player goes up. I'm gonna just keep throwing chalk apparently, using chalk. But that's because. Okay, next. Okay, Kate, did you have a question? You did?
Wait a minute, how
Sorry, no question.
Okay, Kate had one first. Then you. Okay, let them in.
Page 405.
Oh, guys, come in.
I have a question of the.
I'm all stuck. I need to hold on to metal that's grounded.
You want to hold it to a metal?
Well, I'm either net positive or net negative.
Why?
Don't screw it, sir.
Don't screw it.
Don't screw me.
So why are you doing that?
No, think about it. If there's an excess of electrons on me,
Is
then
that
they gotta go to ground. And if there's a deficit, I need them.
What the hell are you saying?
What do you mean, what am I saying?
What are you
This is
saying?
not-
No. Why you want to touch
it's only
something?
with one single touch. You don't need to move it.
Sir, why you want to
Doesn't
touch
take that
something?
long. It's not blood. It's electrons. They go really fast.
They actually don't.
Wait, what the hell is
They
going on?
don't go very
They
fast.
do. They
What's
do.
going on?
Touch the board.
If the difference is a lot,
Do the electrons in a wire move fast?
no. But when you touch it, you feel it because the electrons all go.
Yeah, but you have resistance. And resistance
going on?
affects the flow rate.
Touch the
Okay,
board.
now hold it for this.
Well, it's not good enough. It's obviously not good enough because I'm all stuck.
Sir, grab the tripod.
Yeah, but the tripod is sitting on an insulator.
Dumb shit.
Get that.
Right? I need something that's gonna that's grounded. Okay, what do you got?
Do you want me to read it?
Yes, please. What? I don't have a bouquet.
Suppose you buy a lottery ticket for which you choose 6 different numbers between 1 and 40 inclusive.
Between what?
1 and 40
Between 1 and 40. Yes, ma'am.
inclusive. The order of the first 5 numbers is not important. The 6th number is a bonus number. To win first prize,
Wait, first 5, not important.
The order is not important.
the order is not.
Oh, first 5. Oh boy, I remember this question.
Oh boy, oh boy.
Oh boy.
This is a pre-period.
Oh my god.
shit.
I'm gonna grab my answer. 6th number, yeah?
Is a bonus number. To win first prize, all 5 regular numbers and the bonus number must match, respectively.
Can this question, this is so bad.
Okay, sir, give it up.
I have the answer. Oh, but I don't even have it.
You don't have to screw it.
I'm not going to do this question now. I'll tell you why. It's hard. and I've done it. The answer to the book is wrong, by the way. And it's one of those questions that I actually put down in my notes, which are with Ms. Shevins. So I will give this to you tomorrow-ish. This is gonna,
Tomorrow is next.
I can do it. It's gonna take us like 20 minutes.
Okay, don't do that.
20 minutes.
It's not hard, it's not
Sure.
easy.
When are you going to give us the photocopy of that?
Someday.
Tomorrow is.
Okay, so we're gonna put this one on hold for now. Well, let's do this. Let me do other questions, and then give you the answer better. This is a scary question.
Don't give a question in part C, man.
It's a scary question.
Why are you so scared?
It's because I remember the question.
He's like, crap, no, I don't know what to do with this.
Yeah, it's hard. No, I did it. I had to think about it, and my
Sir,
answer.
can you give us a one period?
No.
Because we can.
Page 377, question 19.
377 question. It's funny, I don't usually remember questions. That question I remember.
Three concentric circles are drawn with a radii of 8 centimeters, 12 centimeters, and 20 centimeters.
I remember this question too, it's stupid, it's easy. Okay, 3 concentric circles. What are the radii?
8 centimeters, 12 centimeters, and 20 centimeters. If a dart lands randomly.
And what was the last one, 20?
20, yes. If a dart lands randomly on this target, what are the probabilities of it landing on each region?
It's stupid, it's just like, here, let's call this region A, let's call this region B. They're basing it on area.
You add them together and then.
Yeah, so I mean, the probability, so they're basing it on area. So the probability of landing in region A is gonna be equal to the total area of the region of success divided by the total area possible.
Well, that's easy.
And technically it's stupid because it also assumes, the solution of theirs assumes that you're gonna hit the target. How do you know you don't hit over here?
Oh, because you're good like that.
Because you're good like that. So we have to assume,
Because if it goes out, you're going to redo it.
does it say that?
No, I'm assuming. And that makes more sense than. No, but it says in that question if a dart lands randomly on this target.
It says that so you are assuming that
Yeah.
Then
so they tell you that.
So you are assuming that you're.
They already tell you that, so you don't have to make the assumption. Okay, so the area of a circle is pi r squared, so you have pi 8 squared over pi 20 squared.
Times 5 12. No?
What are you talking about?
Oh, wait, 20 is
That's it.
That's the first part. Then you need to know probability of region B, right? So region B is the second circle, which is going to be
12.
second circle minus that, so it's going to be pi 12 squared minus pi over the same denominator of pi by 20 squared. And probability of C is going to be
All of them
pi,
divided by 20.
20.
pi times,
20 squared.
I would just write it like this.
Wouldn't this be a negative number?
Is that better? That's easier, right?
So I have a question.
Once you get the probability of this and this, you can just do 100% minus the sum of the first two, right? Probability of A and probability of B. You're making a face, that's why I'm still talking. Do you understand what I mean?
Yeah.
You're good? Naomi, what do you think? Haven't been paying attention? But don't you need to? Oh, you're tired. I am too.
Mr. Sagan,
Yeah.
why are these questions in the probability distribution chapter?
Who cares?
Who cares?
I didn't write the book, doesn't matter. Let's just answer them. Just keep going.
I hope one day I
You can have anything. Yeah, anything.
You might just pick up with this question from.
Yes, sir.
I have a question. Page 396.
Yeah. So that one we're finished with?
Yeah.
Yeah.
Question 14. Okay, so
You make. Hi.
Excuse me, could Janice Lynn come to the main office, please?
You can.
Thanks.
I need.
Where you going?
All I need to do is hold on to some pipe somewhere in like the.
You want to hold on to it. You don't
I'm all charged. I'm sticky, right?
So?
So it's bugging me.
Oh.
Okay, let me find you a box.
Okay. What do you got?
okay,
Go
so
ahead.
Three friends of an avid golfer have each given her a package of 5
Three
balls
friends.
of an avid golfer.
Oh, avid. Oh,
Yeah.
What is
I
avid?
remember this question. Yeah.
Have each given her a package of 5 balls for her birthday.
Okay. So wait. So there's 5 of X and there's 5 of Y and 5. I'll just call this A. And 5 B and 5 and C. Yeah.
Okay, the 3 packages are different brands. The golfer keeps all 15 balls in her golf bag and picks one at random at the start of each round.
Okay.
Part A. Design a simulation to determine the waiting time before the golfer has tried all 3 brands. Assume that the golfer does not lose any of the balls.
Okay. Fine. Yeah. And part B. Because we're not going to design a simulation. We're going to probably do this theoretically, right?
Sir, we'll touch the locker outside.
What?
Touch lock.
But those aren't.
They are.
Are they?
Yeah. There's one way to go.
That looks so weird. If they don't know what's going on.
You thought the principal was gonna walk in and see me rubbing the locker? Mr.
Mr.
Sega. Mr. Sega, are you having
don't
problems?
do it.
Are you having problems at home, Mr. Sega?
No, sir.
Are you lonely, Mr. Sega?
Please don't screw
It's
it.
the second that's in the
That's not. Do you realize what you're saying is not doesn't quite work?
Yeah, it works.
Oh, no, you just need to stab it. Stab it with the hole.
Because the first thing is touch something and then
Let's write the 3 different brands.
Before.
I realize that.
Get him to screw you.
I'm
won't
not
take
gay,
long.
bro. I'm not gay, bro.
So you know what, Milad? You've been. And when? How does it start? It starts out. Okay, before. Okay, yeah. And at the beginning of a round. This is beginning of a round, right? Of round 1. Or before. Before beginning of round 1. Okay, you take out 1 ball. So, Milad, you've been saying, oh, can't you give us a question that involves using some of the...
Finally.
So, before I give away the answer, go into your little math bag, your high school math bag, which is getting heavier and heavier because you're in grade 12 now, and pull out the tool. So I'm telling you, one of the distributions I've taught you is an applicable one in this case.
Geometric.
Yeah, who said hypergeometric? How many of you say hypergeometric? 1. How many of you say geometric?
I said geometric.
Hypergeometric.
Hypergeometric is
Why is it geometric? Why is it geometric?
Geometric is
Trying to find how many times it,
You fail before you. Right. If you define success, what are we defining success? You can define success as trying
Someone is before what?
all 3 brands, A, B, and C, right? Right? So, in other words, failure corresponds to going forward without having tried all 3 brands. And we want to figure out the waiting time, right, associated with that.
So why is it geometric?
Because there aren't a fixed number of trials. Like, theoretically speaking, she could continue playing golf forever and never try all of the brands. Furthermore,
Wait.
this experiment ends by definition.
When she picks up a ball, she puts it back?
No, I think it says she picks up a ball and then she plays a round of golf, right? And then at the end of the round of golf, here, she takes the ball out. And then at end of round, here we can call this round X. And then at the end of round X, she puts it back. Right? That's what it said, right?
Yeah.
Before the round of golf, she takes one out, right? She plays the round of golf. Correct me if I'm wrong, otherwise I'm going to screw
It
everything up.
doesn't say that she puts it back.
But
It
she
says,
does not lose any of the balls, though.
Oh, but it doesn't.
it says the
It doesn't
golf,
exactly
golfer
say
keeps
she's gonna
all
put a-
15 balls in her golf bag and picks one at random at the start of each round. Okay, it says
Yeah, and-
it says the golfer keeps all 15 balls, so that means
So I'm assuming
she's
that
not
she.
losing it. Huh?
I'm assuming she's putting them back.
Yeah, you're right.
Oh yeah, you wouldn't just leave it there.
No, you're right. Maybe they. But why would they write that she keeps them all? Probably means that she puts it back. And okay, so and that's actually also important. That's important for geometric as well. Why is that also important for geometric? That she puts it back.
Each trial is located better from the other trials.
Right. We said one of the similarities between geometric and binomial is that the probabilities of success and failure do not change from trial to trial. And if there's no, so this is with replacement. With replacement, right? And with replacement is important for geometric, correct? Otherwise P and Q will change from trial to trial. So that's good.
Wait, so we can't do unlimited trials for binomial?
No. N is your, well, I guess you, no, you can have a general maximum number of trials of N.
But you can have unlimited for geometric.
Yeah, because geometric is based on the notion of continuous failure followed by a single success, at which time the model ends, or the scenario ends.
Wait, one more question. What about hypergeometric? Is it unlimited trials?
No, it is not. It is also fixed trials like binomial, except the probability of success and failure change from trial to trial because there is no replacement.
Okay,
It's
got it.
dependent. So,
I taught you this already.
No, I wasn't paying.
Makes sense. Makes sense.
I can teach you this.
No, okay, I'm good.
Okay, so now how the hell are we gonna do this?
I have
So the expected value for, this is hard. So the expected value for geometric probability distribution, they told us was Q over P. You have to use calculus for this. It's the sum of an infinite series, right? We're not using that. We're just taking the formula on faith. Is that the right formula?
Yeah.
By the way, if you're not sure, I think you can just flip to the back of the book and look here. You have all of the formulas here on 2 pages. By the way, I'll give you a photocopy of this for the exam. You'll have all those formulas.
So I have a question.
I know you have many, and I'm not getting very far. Okay, go ahead.
Right here, man.
Okay, so why didn't you? Okay, there's a formula for what for P of x equals to Q xp, and there's expected value. Why did you use this? Why did you use that?
Okay, that formula that you're talking about is the general definition of expected value, whereby expected value is just average, as I've taught you. You weren't listening. Okay, we used to define it as just sum of x from I is equal to 1 to n over n. But in that definition of average, you can have multiple identical values. In the expected value definition of average, you don't. You have only unique values of the random variable x, and if you have multiple occurrences of that value, that's why you're multiplying by a weighted average, or the probability. Why it's why weighted average? You're multiplying by probability distribution. We did this. Expected, and I told you that definition of average is used because it enables you to learn other things and do
So
other
we
things.
never
in
used
statistics.
that.
We use that.
We used it yesterday
We used that.
in that question with the roulette.
We use
I did expected value.
No, I'm saying this.
That definition, xi p xi, the definition, sum of xi p xi.
No, but that's I'm talking about P of x equals
Mira,
to
drop the
Q
course, please.
to the power of xp.
P of x is equal to, that's the probability distribution for a
Okay, when do we use that?
let's say you want to know what is the probability that you fail, let x equal 6. What does that mean? That means 6 failures before 1 success. You calculate the probability of success per trial, Q is the probability of failure per trial, and the probability that you fail 6 times before you succeed is going to be probability of success to this probability of failure to the 6 times probability of success to the 1. Okay? Now, can we go on? And that is the distribution that applies here, but they're asking us expected waiting time before golfer has tried 3 brands. So this is geometric, right? This is geometric. Before golfer has tried, we're going to call this success. And then also we have with replacement. If your objective is to try all 3 brands, she goes into the bag. There are 5 A's, 5 B's, and 5 C's. What's the probability? If probability of trying all 3 brands is your objective, is what we define as success. When you go and grab the first ball, What's the probability of success on that beginning part of the chain? 100%. Because it doesn't matter if you grab A, B, or C, you're good.
Yeah, 1.
Or you can call it, if you want, you can call it 15 out of 15 if you even want, right? If you want to. You can take any one of the 15, and so if you take an A, B, or C, you're good. Now,
10 over.
yeah. Let's think this through.
5 over.
Does this make sense so far?
Yeah, so smart.
What does that simplify? The 15, that's the same thing as 1 times, what is that, 2/3? Times 1/3? Equals 2 over 9. So what does that mean? That's the probability that you tried all three. And let's just be careful here. This is an x by x by x. This is a, I hate this.
But sir,
What?
there could be a failure between these 3 trials. Like you can choose the first ball of the first round, and the second ball of the first round, and then the second round, third round.
Yes, this is true. However,
But you are calculating the success right now. Like, you
no,
are
he's
calculating the P.
I'm not disagreeing that you're wrong.
You're calculating the P. So you are using the success.
Yeah, you're right. No, he's very right. He's saying that what I've written so far is that's the probability of success, of immediate success.
You are calculating P, so you are using the success.
No, but he's
Right? You're calculating the P. The P is the successful.
he's saying, look, you could do that. He's saying then you could fail. Like let's say you grabbed A, right? Say you grab A, and he's saying, oh, let's say you grab A again, right? Which would only be a 5 out of 15. He's like, but then you could grab B, and then you could grab C. That's still a pathway to success, is what he's saying.
Sir, I think we should do geometric inside the geometric.
What? Can I just try and think?
You can find the success by using geometric.
Yeah, be quiet.
Okay, I need a few seconds to think. You guys try and do it yourself. Since you're asking me, is okay. Very good. I like that. That makes sense. Okay, break problem up into 3 geometric distributions. 1 per stage, whereby each stage's success corresponds towards overall goal of success, i.e. trying out all 3 brands. Okay, this makes sense to me. Thank you. Now, stage number 1. Probability, so we'll say geometric stage number 1. What's the probability of success for the first stage? It's 100%. Yeah. Okay. And therefore, without even doing the, well, you can write as a formula. Therefore, Q equals 0. Stage 1. Is going to be 0% over 100%, which is 0. Okay? So, on average, when she starts the game, there is never a wait in terms of moving towards our ultimate objective, which is to try all 3 brands. Makes sense. No matter what she does, she achieves success immediately at stage 1. Agreed?
Yes.
I.e., stage 1 is always
100%.
successful. I.e., never any cues. Okay, that makes sense. Next. Stage 2. Probability geometric. Number 2. Okay. As he said, note. Stage number 2 only happens after stage number 1 success. Agreed? Stage 2 doesn't even move until stage 1 is accomplished. Agreed?
Yep.
Because, okay, so probability of geometric number 2 is going to be 10 out of 15, right? If in stage 1 you grab A, brand A, you must grab one of brands B or C. Okay?
Just 2 or 3.
Which is 2 and 3. Therefore, Q geometric stage. This is stage, right? Stage number 2 equals a third. Therefore, E geometric stage number 2 equals 2/3 over a third, which is 2/3 times 3 over 1, which equals 2. Now, keep in mind, keep something in mind here. This is relative to before any rounds played, right? But this is
after one.
relative
After the first round.
to before
Round 2.
it's not necessarily round 2. Well, I guess it is, yeah, because it is relative to round 2, because if you have success immediately here, right, you pull out a ball, you succeed, the whole round has to be played, and then you have relative to before round number 2 is played. Next.
Sir, I have a question.
Yeah.
For the expected value of the stage 2, isn't failure over success not success over failure?
It's always failure over success.
Okay,
Did I
so
do it
why-
the wrong way?
Yeah,
Okay,
it's
over
success
3.
over
Sorry. Q over P. You know, and that's going to be 1/3 over 2/3. Thank you.
So, 3 over 2.
Okay, next. P geometric stage number 3 we're at, right? Is going to be 5 out of 15, which is a third. Therefore, E geometric stage number 3 is going to be Q over P, which is going to be 2/3,
Over 1.
which is going to be equal to 2/3
3 equals to 2.
times 3 over 1, which is 2. Now,
Right.
this is tricky. This is going to be relative to,
Before round 3 starts, no?
it's not necessarily round 3 because you don't know how many rounds happen to, but it's relative to expected, I don't know, I have to think now. So here, on average, on average, you never ever wait to succeed at the first stage, right?
No.
And that means, okay, so that, but then, and then, so on average, you don't wait to start the first stage.
Yeah.
And then you have to wait 1 round, right? Okay? And then relative to that 1 round, you have to play another half a round to succeed. which makes no sense, I guess, because, in a sense, because you can't play half a round of golf, but this is theoretical. Right, so look, you start, you take out a golf ball. You don't have to wait for success, right? You play your full round, and you pull out another golf ball. On average, you have to play another half round relative to that to succeed, right? And I'm wondering, do you also add a 1 to that, or do I just add the 2 to that? That's what I'm wondering. Do I just add the 2?
You add a 1 because that round needs to be played.
But what about the half? What does the half signify?
Same thing
So,
you did the first time.
but I'm not sure. Hang on. You don't play any golf. You pull out a golf ball. Fine. On average, you succeed. You have to play a full round of golf. And after you play a full round of golf, you, on average, have to play half a round to pull out. Yeah, that right. That success is pulling out a golf ball. You're right. You haven't yet played. Right. So this is pulling out ball before playing. And this is also pulling out a ball before playing. So then you have to play the round, I think. And then you have to, again,
You have 3 tries.
and then you don't have to play. You don't play the last round. Because, no need. Since we stop as soon as all 3 chosen, i.e. experiment stops without third ball being played for a round, right? Because it says, the question said, right? Like you don't, it said, what is the expected waiting time? What was it? What was the exact wording?
By the way, your answer is right. Go back to the book.
Use the method described in the section to calculate the expected waiting time before the golfer has tried the 3 different rounds.
Tried the 3 different brands. Oh, it
So you got
depends.
a +1.
It depends on how you.
She gotta try it. So +1.
The answer is 4.5, which is your answer.
Well, I think I agree with Milad. So this gives you 3, 4.5. That's the answer in the book, but there's 2 possibilities here. I have to think this through. Either Milad is saying try the ball means that you have to play it. So Milad wants to say the answer is 5.5, right? Let's just think this through. This is the only thing I want to think through. I think it makes sense. And if this makes sense, then we can accept this answer or Milad's answer. But we have to think this through. Krish, do you follow any of this?
I'm really confused with the half.
Yeah, let's think about it. So let's think about what this means. 0 corresponds to the number of times you have to do stage 1 in order to achieve success. What are we defining as a stage? How do we define a stage?
I guess.
Choosing a golf ball before a round, right? The definition of a stage is choosing a golf ball before playing it for a round. Agreed? That's what we're defining as a stage. So on average, you just go in once. You don't fail, right? Now, then you play the ball. So that's a round. Then you play the ball. We're good to here, right? Is everybody good to there? Next, stage 2. It's the average number, it's the waiting time, because because imagine, if you pull out a golf ball and it's the wrong golf ball, you play the full round with the wrong golf ball, right? And then you put it back in and you go again.
This is saying half.
So this is saying, I know what you're saying. I see where you're confused. You're like, so what does that half mean? That means, on average, like let's say this number was 1. What would that mean? That would mean that you would have on average 1 failure at that stage. And what does it mean if you fail? If it means you fail, it means you took out the wrong one, which means you had to play the round, and then you had to pick the right one and then go again. So that would have been 2, right? So that +1 makes sense.
Plus 1 makes sense.
Yeah, because if this was, let's say this was a 1, what that would mean is, let's say you drew ball A for the first round. You now draw ball A again. Oh shoot, you have to go ahead. See how I said shoot? I'm learning this at the sun and my wife yells at me when I swear. You play the full round, right?
Oh.
You go back again, right? And then you choose successfully, but now you gotta play the full round. So that last part that I said is this. This is the waste.
This is what we don't get.
This is the waste. No, it makes sense. This is the wasted round that you have to play in order to try again to succeed. In other words, a round always has to be played after success. A round must always
But then you're
be
saying
played after success
By
or
writing
failure.
By writing that, you're gonna
Or failure. So on average, what this means is, on average, you play half a round worth of failure before you then play the 1 round of success. Yes.
Sir, in this question, isn't that, how can you technically play half a round? You either play the whole round or...
You're right. It's an average. It's not physically. It's like saying, if I asked you, if you were rolling a die, right? Like we said, the probability of success is getting the 6. Probability of success is 1. Or rolling a 5. Probability of success is 1 out of 6. Probability of failure is 5 out of 6. And let me ask you, on average, how many times do you have to roll the die before you succeed? You get the roll that you wanted. Well, it's going to be 5/6. Bad example. Bad example.
5.
That worked out clean. Okay, but what if, let's think of a scenario here where it won't work out clean. Where the denominators are different, right? Because if the numerators, if the denominators are different, when you divide through, you get an offset, right? By the 6 and the 6.
The success must be bigger than the failure in order for you to get.
Yeah, in other words, you can have, I can't think of a scenario right now off the top of my head, but you can have a scenario where Q divided by P, okay, doesn't come out to being, let's say, it doesn't come out to being an integer. And yeah, it's true that the outcomes are only integer outcomes, or like you can only have a full success, you can't have a half success. But it still gives you an idea, it's an average. It's like saying, it's like when you hear in statistics, or when people say the average number of kids in a Canadian household is, let's say, is 2.2 kids. Well, you can't have 2.2 kids, right? But it still gives you an idea. It tells you that on average, Canadians have closer to 2 kids than they do 3, but more than 2.
Sir, is this a good example if there's a failure? If you roll a die and there's a failure of getting 6, so 6 is the only failure, and the success is 1 through 5. So you get 1/6 divided by 5.
No, probability of success is going to be 5 out of 6. But it's still a problem. It's gonna be 1/5. Yeah, but look, when you divide this by this, you have 1/6 divided by 5/6, which is 6/5.
Which is 1/5.
No, yeah, good, yes, good. Good, yeah, right. No, you're right.
So does that mean like this?
So that means, yes, excellent. So that means on average, sorry, yeah, that's perfect. So that means on average, you have to play the game 1/5 of a time. You roll the die 1/5 of a roll to succeed. Doesn't make sense physically, right? You can't roll a die a fifth of the time. But it gives you an idea, right? In other words, it would make more sense if you were talking about 1 in 5 rolls, I suppose, right? On average, 1 in 5 rolls.
Is failure.
Right. No.
This is success.
About 1 in 5 rolls will give you 1 success.
No.
Yeah, because remember, because this is the expected value for geometric, right?
It's only
And
failure.
geometric it corresponds to the number of failure, it corresponds to failing and then succeeding once.
No, but the success is 5 out of 6. How can you only succeed once in 5 trials?
It has to be one fail and 5
No,
trials.
it means that 1 over 5, first of all, means that on average you'll have a fifth of a roll
Oh, we know.
before you succeed, right? So let's leave it at that. On average, you'll have a fifth of a roll before you succeed. It's not physically possible, but
Theoretically.
what is physically possible is that, let's say you roll and you succeed immediately, which is a 0 waiting time in that case, but then he runs the experiment and he didn't succeed until 2 rolls, and so on and so forth. And you average all of those numbers out, you average the waiting times associated with each of those, and it comes out to being a fifth. See what I'm saying? Because it is an average. Expected value is an average.
Having 5 chances.
Like I said, 2.2 kids per household. Not physically possible. Okay? So, back to this thing. So, waiting time. There are 2 aspects to this. There's the waiting time associated with you choose successfully the first time, and then you must play a round of golf, following success or failure. Then, on average, you waste a half of a round. What does that mean? It means you fail. It means on average, you pull out the wrong ball, right? And end up having to play a half round of following the failure. But guess what? To move to stage 3, you still have to succeed. And when you succeed, you then have to play the 1 round following that, right? And then, following that, you, on average, have to play 2 rounds. That's 2 rounds worth of failure, meaning, you didn't get the 3rd ball, so you played a full round of golf. You came back, threw it back in. You didn't get the 3rd ball. You play a round of golf. And then you go in and you're like, I got the 3rd ball. But in the last case,
You know, play around.
but I would agree with Milad, because it says tries all 3 balls. It doesn't say chooses all 3 balls. And so if it says trying all 3 balls, to me that means playing the ball. So I would agree that based on Milad's definition,
It's 5.5.
I would cross this out, I would put in a 1, and I would put a 5.5. Because it says trying all 3. It doesn't say choosing. When you simply grab one of the balls out of the pack, have you tried it? I would say no. You've chosen it. So I would agree with what he's saying. I would say the answer is 5.5. That's a hard question. Very hard. Very hard. Yeah.
For the 1 over
That's the way you would have done it, Johnny? That's the way you were going to do it? Yeah.
No. Question 18407. Which page? 407.
How many of you guys get that? Okay, no? Comme ci, comme ça? Where does it fall apart, Kate? Oh, that's not good.
No, it's okay.
Do you think it's okay? Okay, what is it, number 18?
Yeah.
Go ahead.
Of the 15 students who solved the challenge questions in a mathematics contest, 8 were enrolled in
They answered, they got all the questions right? Okay, yeah.
8 were enrolled in mathematics of data management. 5 of the solutions are selected at random for display.
Hang on, 8 of 15 in data. 5 of the what?
5 were randomly chosen for display.
5 solutions.
So basically they show
5
to
of the
people.
5 of the students?
No,
5 of the solutions.
It's 5 out of 15.
So it says for A, it says prepare a table and graph of the probability distribution for the number of solutions in the display that were prepared by mathematics or data management students.
Oh my god. Okay, let's think about it.
So this
There
is-
are 15 students. 8 out of 15 are in data management. They're going to display. So we have 5 out of 15 solutions displayed. Create a table that.
that the display that were prepared or done by data students.
Let me read.
So I can read of the 15.
Fine. Can I read?
Yeah, sure.
8 were enrolled in mathematics and data management. Yep. 5 of the solutions are selected at random for display. Prepare a table and graph the probability distribution for the number of solutions in the display that were prepared
By the data students.
by mathematics. What does that mean?
Basically, sir, it means that
So the 5 questions that were chosen were done by the data students.
But what does that mean, done by the data? Oh, because, so meaning,
So it's showing the
okay,
answers of
oh,
the
when you
data
say
students.
randomly displayed,
sir,
It's showing the answers of the 5
Sir?
data students.
to what?
sir.
What do you mean?
Yes.
So question.
Basically, just imagine that there are 8 kids in this class. Okay. There are
15 kids.
No, there's 15 kids in the whole school who did the math contest.
Yeah, 15 kids in the class that did the math contest, 8 of whom were data management students. Go
Yes,
on.
right?
And pass that.
And there were 5 solutions out of the 15 kids that did the math contest and the solution.
Okay, so when we talk about a solution,
Yeah, we're talking.
Yeah,
we're talking about a full test.
yeah.
Yes.
We're not talking about a question
Yeah.
on the test. You mean
Or
a
maybe
full
it-
test.
it's-
It's the same thing. Yeah.
Whatever.
Something.
Okay, so we grabbed, so 5 out of the 15 papers
Yes.
were randomly grabbed.
Yes.
Okay, and then the question is, again, what, and then what did they ask?
Prepare
Probability distribution for?
for that the 5 that were chosen were done by the data students.
5, okay, and there are 8 students.
Yeah.
Oh, okay, so we have
15.
8, so we have, that all 5 are from the data?
Yeah.
But that's 8 choose 5, okay? You have 8,
It's a hypergeometric question.
yeah, but there's no distribution. Oh. Okay, they want anywhere from 0 to 5.
Yes.
Okay, got you. Because when it says that all 5, I figure they just mean this. It's not a distribution, it's just one answer. But the only way to make it a distribution is to do it this way. So if we do it that way, we have A choose 0,
It's a table graph.
right? Times, what is 15 minus 8? 7. Take 5 over 15, choose 5.
So it's hypergeometric?
Well, yeah, and of course.
Well, yeah, of course.
What else? What? Why do you not know that it's hypergeometric?
I'm just making sure.
No, you're not. You're not
It
sure.
says hypergeometric.
If you're making sure, that means you.
I said it's hypergeometric, right?
Who cares what you call it? The bottom line is, one possibility is that all 5 tests, that none of the data management students have a solution in there. Then 1, then 2, then 3, then 4, then
5.
all 5, right? Call it whatever you want. I need 4. I need
3.
3. The sum here always has to be 5, right?
2.
1.
55.
They want you to graph it?
Yeah, but we don't really need to do it.
Yeah.
Unless they're gonna ask us that.
So are you ready for the next test?
Yeah, I think so.
Is it? You said it is Mr.
Now, you could do it this way, or you could do it with multiple stage probability multiplication, right? I taught you that. You don't have to do it this way. You can do it as, how many questions are there?
5.
Oh, sorry. So that the first question has got to be from the non-data student.
First solution, you mean.
Yeah, the first solution. So that's a 7 out of 15, right? Agreed? And then you need that to happen, then it's a 6 out of 14, right? And so on and so forth. So it becomes a 7p, how many? 5? 5 questions?
Yeah.
Or 5 papers? 15p5. Is that the same as that?
Sure.
Sure it is. Look. That's combinations, that's permutations, that's an offset, right? You see the offset right there. Because that's divided by 5 factorial, divided by 5 factorial, and you'll get the same thing. So you don't have to use this if you feel comfortable with multiplying probabilities and actually seeing the fact that P, notice, when I did it that way, you could see better why it's not binomial. Why? Because the probabilities of success were changing because it's without replacement. Without replacement. Anyways, I don't know what these numbers are. But the bottom line is that you would have a y-axis or a vertical axis of p, xi, a horizontal axis of xi, which would run from 0 to 5, and you'd have to put in some values. And
There's a part B.
what are the probabilities? Anybody know?
No.
I don't know. You gotta have some dots. I don't know what the dots are.
Let's do part B.
It's just a.
You guys understand that part?
Yeah.
Okay. What's part B?
Part B says, what is the expected number of solutions in the display that were prepared by data students?
This is height or geometric. What was the formula for it?
No idea.
You just go to the back. You weren't expected to prove
R
this one.
times A divided by N.
R times A over N. Well, now you got to remember what all these things were. A is the total number of trials, right? Which is 5. A is the total number of.
Successful.
No, I think A is the total number of available successes, I believe.
It's RA.
Objects.
So,
It's RA over
RA over N.
It's the same.
That's the same thing.
Oh, yeah.
Okay, sorry. What are A and R?
Okay, A is total number of available successful choices.
Which is going to be 8, right?
Yeah.
And what is R?
R is the total number of objects that must be chosen.
Which is, no, 5. So what is N? 15?
N is the total of number of choices.
15. Right? Okay. Questions on that? How do you know this formula? You just go by copying. You didn't prove it. You don't know it. The only one we proved was binomial, right?
So on the test, are we supposed to memorize it?
No, it's giving.
I don't know. I have to ask Gallo. On the exam, for sure not. On the test, let's ask Gallo.
But sir, you said for the exam, you're going to give us the
Yeah, that's what he said.
Yeah.